Hi, this is Mr. Chen. You're welcome to my study room. It's a joy to have you join me because I know we are going to learn one or two things together. Please hit the subscribe button if you haven't done that yet for more updates of videos like this. Let's go straight into today's studies. Today we are doing exponential equations. Exponential equations, what are they? They are equations with variables as exponents, and our aim will be to find the value of each variable. For example, if we have 5 exponent x being equal to 5 exponent 3, then we'll say that the value of x is 3 because for what is at the left hand side to be equal to what is at the right hand side, unless the x here is equal to 3 because they have the same base. Not only that, we can also have a situation where the exponents are the same but the bases are different. For example, let's say x exponent 7 equals 2 exponent 7. Then for this equation to be true, unless x is equal to 2. So these are exponential equations. Let's take an example. Solve 8 exponent x equals 32. Our aim of solving this equation is to make the base of this left hand side and the base of this right hand side to be the same so that we can equate exponent. And when we look at the 8 and the 32, we can have a common base which is 2, and 8 is 2 exponent 3. So 2 exponent 3. Remember, okay, let's do it this way. Then 32 is 2 exponent 5. Remember, one of the laws we learned is when the exponents are multiplying, we just multiply them. So this becomes 2 exponent 3x being equal to 2 exponent 5. In this case, since the bases are the same, we just have to equate the exponent before this equation can be true. So that means this equation will be true when 3x is equal to 5. We are looking for the value of x, so we divide both sides by 3, and our x is going to be 5/3, which in extension can be written as 1 whole number 2/3. So it means that the equation will be true when x is 1 whole number 2/3. Let us take another example, and this will be, let's make this example 1. We go to example 2. This is 25 exponent x equals 125 exponent x minus 1. The same approach here. We are trying to make the base of this 25 and 125 to be the same. So here, what will be the common base? Good, the common base will be 5. So 25 here is 5 squared, and the 2 times the x at the top will give us 2x. This will give us 125 is 5 cubed. And remember, that is multiplying a binomial here. So we have to put it in parentheses so that we open it gradually, x minus 1. Because if you don't put it in parentheses, the 3 will end up multiplying only the x and not both of them. But here the 3 is multiplying both of them together. So the right thing will be to put it in parentheses so that you can work them out. Again, we have the common basis already. So the base is 5. Therefore, we can equate exponents without trouble. So let's go ahead and equate the exponents. Then we can go ahead and solve the linear equation now, which is 2x being equal to 3x minus 3. This 3x is bigger than the 2x, and I don't want my x to be negative, so I will group the x terms to the right hand side rather, and bring the constant term to the left side so that I don't have negative x. So this one comes to the left, become positive 3, which will be equal to 3x is already at the right side. Now I'm grouping 2x to go and join, it becomes negative 2x. So 3 will be equal to 3x minus 2x is 1x, which is the same as x. Therefore, our x will be equal to 3. Our x will be equal to 3 for this equation to be true, unless our x is equal to 3. So that is how we work it. Let's have another example. Let's call that one example 3. Example 3, we have to solve 243 exponent 2x times 9 exponent negative 1 all over 81 exponent x plus 1. This equals 1. Good. So we are solving 243 exponent 2x times 9 exponent negative 1 all over 81 exponent x plus 1, and the whole of this should be equal to 1. So first of all, we need to find the common base. You need to find a common base for all of them again, so that this will be very easy for us. The common base here is 3, and 243 is 3 exponent 5. Remember, there's a 2x there. Then times 9 is 3 squared. There's negative 1 there. All over 81 is 3 exponent 4. Then we have x plus 1 there. Then, because you are expressing each of them as the base of 3, it will be appropriate to express the 1, 2 as base 3. And remember, in an earlier video where we had the laws of indices, any normal exponent 0 is 1. So here we just have to choose the same base here to make k3 exponent 0 to be the same as the one we are looking for. Alright, so let's work it further to have 3, 5 times 2x will be exponent 10x. Then times 3 exponent 2 times -1 is -2. That will be equal to 3 exponent 4x plus 4. And this should be equal to 3 exponent 0. Alright. So by applying the laws of indices, these two are multiplying. So we add the exponents and then this is dividing. So we subtract the exponent. That is what we are going to do right now. To have 3 exponent 10x plus -2. Then let me use the division sign so that we all understand. Divided by 3 exponent 4x plus 4. This will be equal to 3 exponent 0. Good. So division, the second law says that when two numbers with the same base are dividing, we subtract the exponent. For those who have forgotten, can go back and check my video on the laws of indices. So this will give us 3 exponent 10x minus 2. Then minus, remember this again that this is a binomial, so you don't just bring the minus, you have to put this in parentheses. 4x plus 4. Then this will be equal to 3 exponent 0. Good. So now we open the parentheses to get 3 exponent 10x minus 2 minus 4x minus 4. This should be equal to 3 exponent 0. Good. There are like terms, so let's work on the like terms of 3. 10x minus 4x will give us 6x. Then -2 minus 4 will give us -6. Should be equal to 3 exponent 0. Here we have the bases are the same, so we equate exponent. And we always do this only when we have one term at the left hand side and only one term at the right hand side. That's why we equate. If we have more than one term, we have to go ahead and work it so that we can have only one base here and one base here. Then we can equate without problems. So now the bases are the same. We equate exponent. That means 6x minus 6 will be equal to 0. And 6x will be equal to positive 6 when the 6 comes to the right hand side. We divide both sides by 6. So our x will be equal to 1. Goes here 1, goes here 1. Our x will be equal to 1. So this means that for this equation far here, number 3, to be true, unless our x is equal to 1. Let's take another example to help in our understanding. Example 4. 1/3 into bracket 64 exponent y, then equals 1/12. We have to solve this. So again with this one, we are trying to work it out so that we can have indices, because that is the main aim of these exponential equations. Our main aim is to express them in such a way that we can have common base at the left hand side and the right hand side. Then we equate exponents. So how do we do that? First of all, here we cannot open this bracket just like that because the 64 is carrying an exponent y and the 1/3 is also standing on its own. So we cannot just use the 1/3 to multiply the 64, while the y will be hanging there. So we consider the 1/3 as a coefficient to this. So just like we do in normal algebra, when we have a variable being multiplied by a fraction, we cross multiply with the denominator of the fraction to make it a whole number. That is what we are going to do. So here we are going to have our 64 exponent y to be equal to, when we multiply both sides by 3, we are going to have 1/12 times 3. Good. So this 3 goes here, 1 goes here, 4. That means that our 64 exponent y will now become 1/4. All right. Then we can see whether we can express this 64 and then this 4 in a way that each of them will have a common base. That is what we are trying to do. Yes. And I think the common base here will be 2, because 2 exponent 6 will give us 64. Let's just confirm that. So 2 exponent 6. Yeah, so that is 64. 2 exponent 6 is 64. So we are going to have 2 exponent 6y, which will be equal to 1 over the 4 here is also another base 2, so 2 squared. Then remember, in our lesson on the laws of indices, we stated some of the law. One of the law as, if you are having 1 over a number and you don't want it again to be a fraction, you express that, you make the denominator to stand alone and negate the exponent. So that means 2 exponent 6y is going to give us 2 exponent negative 2. All right. Now they have common bases now. So 6y will be equal to negative 2. Then we are looking for y, the value of y, and not 6y. So we divide both sides by the 6. And that will give us y to be negative 1/3. So when the question comes, this is how you are going to work it. If the base here is not the same as the base in the bracket, you consider that one like, or you consider it as a coefficient. And whatever you do in the normal algebraic expression with a coefficient, that is what you will do. So that is how we can go about it. So let's solve another equation, which is 27. So let's make this one question 5. (27) exponent x p equal to 3 root 3. You have to find the value of x. So this one just look a little scary, but it is not really as scary as it can be, as we might be thinking. Because first of all, 27 exponent x will be equal to, don't go and use calculator to be multiplying this, because we are expressing our answers in indices. So if you multiply, you are going to get decimals, which will be wrong. But rather, we should see this as 3 times square root of 3. All right. So when you have that, remember one of the laws says that the square root of a number is the same as the number exponent 1/2. So I keep referring to the laws of indices so much because the whole indices thing is based on the laws. So if you are watching the video right now and you don't know the laws very well, you can go back to one of my videos on the laws and then you take it right from there. I explained each of them very well. That is why I'm just using them here like that. So here you see that 27 can be expressed as a base 3. We have base 3 here. And then here too, we have base 3 since I just explained that. And 27 is 3 cubed. And remember the x is there, so 3 times the x will give us 3x. This will be equal to 3 exponent 1, just for it to look like indices. 10 times 3 exponent 1 half, which I explained the reason for it. So 3 exponent 3x is going to be equal to 3 exponent 1 plus 1 half log 1. The bases are the same, they are multiplied, so we add the exponent. So that is going to give us 3 exponent 3x being equal to 3 exponent 5. Okay, let's do the addition at once. So 3 over 2. 3 over 2 when we add the exponent. Then here the bases are the same, so we equate exponent. We are going to have 3x being equal to 3 over 2 because these two are the exponents. So that we all go along, I'm supposed to divide through by this, by the 3, but I know some people will be having challenges with that. So instead of dividing through, I'm going to make both of them whole numbers by cross multiplying these 2 to come and multiply the 3 here to give us 6x being equal to 3. Alright, then now we are looking for x, so we divide through by 6, and that will give us divided by 6, divided by 6. This one goes here, 1 goes here, 1. This one goes here, 1 goes here, 2. Therefore, the value of our x is going to be 1 half for the thing to be true. So that is how we are supposed to go about this. Question 4. Then there are other questions. Let's take one more question. Let's take one more question and look at how it is. Every question and how to go about it. So let's see how this one to go. So we have to solve 2 times 3 exponent x plus 1 being equal to 3 exponent x, the whole of this plus 45. So we have 2 times 3 exponent x plus 1 being equal to 3 exponent x plus 45. So I want to explain a very important thing about this, first of all, before we even start working. So all the laws of indices we have studied, we've seen that they work only when the bases are the same. That is number 1. And then none of the laws also speak about addition. So immediately we see addition in it, we have to think of other ways of solving it and not rigidly applying the laws, so to speak. So that is what we are going to do right now. Since there is addition, we are going to work it out in a way that will not involve applying the laws straightforward from the beginning, because none of the laws talks about addition. So the addition here will be a challenge. Because of that, let's break it down using the laws. And this will be the same as 2 times 3 exponent x times 3 exponent 1 based on the first law. And this is going to give us 3 exponent x plus 45. Alright. So by this, it is just like an example we solved earlier, where we have 1/3 multiplying a number, and we have to consider it as an exponent. So that is what we are going to do. So here, the first thing we'll do here is to multiply the other numbers that are not carrying a variable exponent. So this is 2 and 3 exponent 1 is also 3. So that is going to give us 2 times 3, which is 6 times 3 exponent x. And that will be equal to 3 exponent x plus 45. So right here, we have a number. We can safely say here that the base here is 3. The common base here is 3. But then we have a number which is 6. And that cannot be expressed as base 3 number. And we also have 45 here, which cannot be expressed directly as a base 3 number. And then, more importantly, there is an addition here, which is not in any of the laws. So how do we go about that? When we have a situation where we have a constant, and then an addition in it, after which we have an indices carrying an exponent, or indices carrying a variable exponent, then the best thing would be for us to replace that variable with that indices with another variable. That is, we will let 3 exponent x be equal to another variable, let's say y. So that wherever we see 3 exponent x, we fix y. Then the whole thing becomes a linear equation where we can easily solve like we have been doing. So this is going to be 6 times y being equal to y plus 45. Right. So at this level, everybody can solve because this is what we all know. So 6 times y will give us 6y, which will give us y plus 45. Let's group like terms. 6y minus y will be equal to 45. Right. 6y minus y will give us 5y, and that will be equal to 45. We want y, not 5y, so we divide through both sides by 5. 5 goes here, 1 goes here, 9. So our y will be equal to 9. Good. Our y is equal to 9. There's no problem with that. But let me just take you quickly to the question that the original question doesn't have y in it. And the variable we are looking for is y. And remember that we let the 3 exponent x to be y so that we can have a linear equation to solve with. So now that we got that, we have to make sure quickly we replace our original 3 exponent, our y with the original 3 exponent x, which is in the question we have been given. So we'll say that because the question doesn't ask us to find y. So when we find y and we stop there, we have not solved the question. So we'll say that but y equals 3 exponent x. So that means now wherever we see y, we are bringing back our 3 exponent x. So 3, this implies that 3 exponent x, we are just fixing it here. 3 exponent x will be equal to 9. So here there is 3 as the base, and then 9 can also be expressed as base 3. So we'll say that 3 exponent x will be equal to 3 squared. And since the bases are the same, we'll say that therefore the value of our x is 2. And this is how we solve it. So let me just take my time to go over the whole thing again. We said that when you are given an exponential equation where the numbers cannot be expressed to have the same base, which is the basis on which we started this, and also there is an addition, then it will be very difficult to just try to express each of them as the same base and equate exponents. So the first thing we'll do will be to break down the question further so that we'll have only the numbers, we have the basis carrying the exponent as monomials, meaning that no more binomial. So here, instead of x plus 2, which is a binomial, now we have the x standing on its own, and then the 1, 2 standing on its own, applying the laws of indices, of course. So this means that for us to be able to solve exponential equations effectively, unless we know the laws of indices very well. And like I said earlier, I have a video on the laws of indices, so you can check it if you're having problem with them. Then now that we have that, we now have the indices on its own with a monomial exponent. And then that will be very difficult because experience has shown that some students will be trying to multiply the 6 by the 3, which is not possible because we cannot multiply the bases and leave the exponent hanging. The right thing will be for us to express this one to be a whole number first, standing on its own, before we can do that, which is not possible because we don't know the value of x. So to have it easy, we have equated the 3 exponent x to be y, which is now a whole number standing on its own with exponent 1. And then looking for that value, we can substitute the 3 exponent x back, which we have done here, and that led us to solve the equation. But for those who are having challenges with how can we brought to y and then back to x, then they can probably go with the normal one. That one we will use the numbers directly. So that means when we have a 2 times 3 exponent x plus 1 being equal to 3 exponent x plus 45. Then here we are just going straight forward by doing 2 times 3 exponent x times 3 exponent 1. Remember law 1. That will be equal to 3 exponent x plus 45. Then here we are multiplying the numbers without a variable as exponent. So here 2 times 3 is going to give us 6 times 3 exponent x being equal to 3 exponent x plus 45. And I just said earlier that we cannot multiply these 6 and the 3 because they are moving together. They are moving together. And the laws of indices say that if two numbers are carrying exponents, for you to be able to multiply them to make sense, unless the bases are the same. But here the bases are not the same. So let us not even try to multiply them. So we'll just carry the 6 as a coefficient to the 3 exponent x because they cannot multiply. So that becomes 6 into bracket 3 exponent x, which will be equal to 3 exponent x plus 45. So this is what is going to happen here. 6 times 3 exponent x, we'll consider it as 6 of the 3 exponent x. And here, if you permit me, I will say 1 of that, which is not showing. So that means that they become like terms now. So you are going to have 6 of the 3 exponent x. But here they are adding. So when it comes, it becomes negative minus 1 of the 3 exponent x. And it will be left with 45 alone here. So 6 of the 3 exponent x minus 1 of it will give us 5 of the 3 exponent x. Sorry, 5 of the 3. Let me just rewrite that. 5 of the 3 exponent x. And that should give us 45. We are still taking the 5 as the coefficient to the 3 exponent x. So we divide both sides by 5. Then 5 goes here, 1 goes here, 9. So that means that our 3 exponent x will be equal to 9. And again, we come here now. So that is 3 exponent x being equal to 3 squared. Therefore, the value of our x is going to be 2. since they have the same basis, which is the same as this. So any of these two approaches will be okay to help you out with it. Because I replace the 3 exponent x here by the y, because some people, when they get here, they'll be tempted to multiply the base without considering that there is an exponent, and that will make the whole work wrong. That is why. But if you also think replacing it with a y, it will confuse you that how can we started with x and then y, then you maintain this one. So it's up to you to work more examples with each of the approaches so that you decide on what to take. You have to try this, and that is 4 exponent x equal to 128 root 2. In case you forget what to do, check example 5 of this lesson, and you see that the only difference is that the bases are different, but then you follow the same approach. And when you finish, leave your answer in the comment box for me to check and see whether you're able to do it well. I wish you very well. But before the whole session for today comes to an end, some questions will follow. You pause this video and solve them and check your answers to see if they are right. So that is how it's going to be. So expect the questions from now. Pause the video, work them out, expressing this thing. Thank you. Good. So that is where we end today's lesson. I hope you've enjoyed it. One of the basic things you need to know about this is that unless you know the laws of indices, you have difficulties with some of these things. So you need to get the laws of indices well, because this topic is governed by its own laws. That is why you have to know the laws first before it guides you. So in case you are having challenges with this, just go back to my video on the laws of indices, and then just go through one by one and get back to the question, and I'm sure you'll be fine. Right. This is not the only video on exponential equations. We can have some that are quadratic equations, you can have some that are simultaneous equations, and there will be separate videos for each of them. So just subscribe to my channel for more updates on this and many more. Thank you for joining me in my study room, and I hope to see you again. Bye bye.